Oh, okay. Oh, it says recording in progress. Yes, okay. And then you've got a couple announcements. Awesome. A whole page. Oh, wow. Okay, that's a lot. Okay. Good.
Good morning, everybody. It's still morning for 2 minutes. Welcome to our Center for Southeast Asian Studies Friday seminar. I have some announcements. Next week, we are going to have Matthias Fibiger, who is from the Department of Business Administration at Harvard Business School. And he will be talking about Suharto's Cold War, Indonesia, Southeast Asia, and the world. There are flyers for that on the back table. If you're interested in coming and would like to eat lunch, there will be an email sent out on Monday with a link so that people can order their lunch. It is capped at 20, so make sure you get in quickly and order by Wednesday afternoon. November 15th from 6 to 7:30 p.m. is the Getsi Community Book Read with Alice Beeben, the author of Unwritten Rule, State Making Through Land Reform in Cambodia, and winner of the 2023 Bender Prize. Professor Ledgerwood and myself are the discussants for that book read, so it should be pretty interesting. Flyers for that are also on the back table. We have an exhibit opening, Food for the Soul, Belief and Healing in Burma. The opening reception is Friday, November 17th from 5 to 7 p.m., curated by our very own Professor Raymond from the Burma Art Collection. International Education Week is November 13th to 17th, Monday and Tuesday from 9 to 11. There will be language tables in Dusable. Tuesday at 2 p.m. in the Campus Life Building 100, where we are right now, there is a special lecture. NIU postdoctoral fellows from Indonesia, Tifa Noor Amelia, who is an assistant professor at Perbanas Institute, and Andy Ghazli Satria Amal from the Indonesian National Police, who are with us this semester, will be presenting a joint paper together on investment trends on millennials and fintech fraud mitigation. Thursday from 5 to 7, also in here, we have Culture Fest, our annual event. And then, of course, on Friday, we have Matthias Fibiger coming back. I would like you to save the date as well for December 6th around noon, 11 to 1. We have Soup at the Center, our event where we all bring soup and we sit down and talk about the semester and look forward to the next one. This is a very special event because it will be our center farewell to Professor Raymond and to Nancy Schuneman, who will be retiring for the second time from the CL program. So without further ado, I'd like to invite our guest today, our homegrown talent, Professor Lanchevsky, to come to the podium.
Okay. Well, thank you all for coming today. I'm going to get rid of the chat feature up here. Oh, yeah. Hey, there's everybody. Okay, awesome. So today I'm going to be talking about groundwater pollution in Southeast Asia. Basically, the title of my talk is "What Did I Do on Sabbatical?" And so this is going to be a whirlwind tour of some of the different things that I was doing on sabbatical. For some of you who might not know me, I'm what's called a contaminant hydrogeologist. I love pollution. And so if there's a toxic waste landfill, I will probably be there in any country. So sometimes when people say, oh, you go to these countries, I'm like, yes, and I saw your landfill, your sewage. You will be seeing some sewage today. I am a professor in the Department of Earth, Atmosphere, and Environment. Last spring, I was a Fulbright ASEAN research scholar to Cambodia and Thailand. I'll talk a little bit about Myanmar today because it was supposed to also include Myanmar. And so I'm talking about groundwater and water quality in Southeast Asia. And my other area of research is on impact of tourism in the Yucatan Peninsula, so Cancun. So when you go on vacation in Cancun, what do you do to the environment? So I study groundwater. And one of the reasons I study groundwater is when we look around, a lot of people are concerned about marine and lakes and surface water. But when we look at fresh water resources, which only make 3% of all of our water, most of it is frozen in ice caps right now. But most of our fresh water that's available for us to drink and for life is made out of groundwater. And so it is a very important resource that is found everywhere, but it's below the ground. So people tend to forget it. They forget that what we do at the surface impacts one of our major resources. Groundwater is important, especially for the agricultural sector. Around the world, 70% of groundwater is used to grow our food. I'll be talking about rice in Thailand, and so we're eating rice today, and so you'll be hearing some more about that. 22% of it is used for domestic, for drinking water uses, and 9% of it is used for industry. And so groundwater is a hidden wealth of a lot of nations. And so part of my job during my sabbatical was to talk about groundwater, to educate people about it, to look at resources and what we can be doing about groundwater for the future. So like I said, I look at pollution. Anything that we do at the surface impacts that groundwater. So if we have, industry, landfills, septic systems, whatever we do is impacting this water that's below the ground and can really cause a lot of problems. So today I'm going to really be focusing on three different countries. I'll be talking about Myanmar, Thailand, and Cambodia, looking at different issues within them, and then pulling them together to talk about how communities, especially very urban areas, what we're doing and what can we be doing in the future. So first, I'm going to start off with Myanmar. This one is really about saline water intrusion and salt water in there. This project is a little bit older. It's from 2020, and I've been working on it with Dr. Chitwitty U, who is sitting over here. This was going to be one of our projects we were going to be working on, and this was part of my Fulbright. But I'm going to talk about it, and we'll see where we go with it. I was working at the University of Yangon. This was back in 2020, right at the beginning of the pandemic. So like that week that everybody was supposed to come home from overseas, I was in Myanmar finishing up this project. I'm going to talk today about a project on groundwater again, and this is in the Dala region, which is right across from Yangon. So for people, most of the people here know, this is Yangon in Myanmar. We had sampled because part of what I was doing was looking at water education. So how can we do curricular development? And so I was showing and working with faculty members on how do you sample groundwater and how do you test water quality? So we had sampled some wells over in the city of Yangon and found the water to be really good. Like it was really high quality. And then we were talking about Dala, which is right across the Yangon River, having really salty water. And they're right next to each other. The wells were at similar depths. So why was there this big difference? And in this picture here, on this side, we're in Yangon, and on this side is Dala. And it's just right across the river. Why is there such a big difference in water quality? So we went over to Dala, and one of the things that we talked to the community members, because this is one of the things that we do, is there's all these pockets, and like right here, you can kind of see it. What happens is during the rainy season, these fill up, and then this becomes their drinking water supply during the dry season. So during the dry season, people are taking buckets, going out there, collecting the water, and then bringing it back to their homes. And I'm like, well, why aren't you drinking groundwater? Because it's already clean. You don't have to deal with this. So we looked at some of the groundwater wells and we went to some of the homes, and the people were like, we can't use it for drinking. And so we started doing some testing of this water. Here we were doing some preliminary testing of water in there. You can see that it's very high. There's a red color to this filter because it was high in iron into there. And we were comparing the water quality between these two. So we went and sampled 4 tube wells, and this is where Dr. Chitwitty U was helping me. We were looking at some wells that were inside of the city, and then some of the wells that were along here in Dala. The wells were about 100 or 50 feet deep. The ones in downtown were 100 feet deep. So we're not talking very deep wells, but they're different. They're about the same in there. So when we looked at Dr. Sain's well, she was a Fulbright scholar here at NIU. We looked at her well, the water quality was excellent. I mean, so we were like, okay, so you don't have any worries with your water. So I took some water from these different wells. Here's the sampling, and I was sitting in my hotel room. A lot of times when I'm doing my research projects, I set up labs inside of hotel rooms or inside of my house to get work done. So here I am working on sampling and testing the water. And so what we noticed in these wells was there was really high conductivity. So it was very salty water in Dala versus Yangon. So even the ponds that they were collecting, because it was near the end of the dry season, had a lot of salt into them. And so we were like, okay, so they're very salty. It is close to the ocean. So could this be saltwater intrusion? We looked at the water and we did a fingerprinting of the water. So one of the things that we did was you do a geochemical testing. I'm not going to talk too much about it here, but just basically we look at the full geochemistry of the water, and that kind of gives us a fingerprint of the water. And we looked at it and we noticed that the water is very different in the water that's on one side of the river versus the other side. They're not the same. So what is causing this differences in this aquifer, which is just separated by a river, which shouldn't impact down 100 feet? So we were like, okay, what is causing these problems? And so this was going to be part of my research project I was going to work on over there and stuff. But as we all know, there is no next steps until there is a future for Myanmar. Sorry. This is the next steps for Myanmar. There is nothing right now. So we're going to leave it right there and move on to Cambodia in there. So Cambodia. This impact I'm going to be talking about is impact of urbanization. So what happens when we have massive urbanization that occurs inside of a city that's uncontrolled, and uncontrolled urbanization that happens? And also the importance of wastewater treatment plants. We take for granted in this country, wastewater treatment plants, when we flush the toilet, something happens to that water, it gets treated, and we have a nice clean environment. And we'll talk about what happens when you don't have wastewater treatment plants. So I'm going to be talking about water quality in Bang Chek Ek, which is a natural wastewater treatment plant. This is a follow-up research from my former fellow graduates, from one of my former students, Sammy Malo. He, back in 2017, he was a graduate student here, and we had looked at a project at this, and then I wanted to see what happened 5 years later. So we went back to the same sites that he had sampled 5 years previously into there. So what were we looking at? Well, the city of Phnom Penh is quite a few million people in the city here. And what they do for their wastewater is there's 2 wastewater lagoons, they're wetlands on the north side and the south side of the town. So I'll show some pictures of that. But basically, every time you flush a toilet, you're running water or anything, that water drains into these wetlands. And then as it goes through these wetlands, it cleans up the water before it gets outlet into the Basak River, or well, I'm only going to be talking about this other one, so into the Basak River. So in 2014, they decided they needed to do more urbanization. So the city needed to grow. So where are we going to grow? Well, let's fill in the wetland. It's just water anyways. What's the big deal? So they started, as you can see, this is 2014. This is that same wetland here. And what they're doing is they're piping in sand that they're collecting from the Mekong River into there, and they're putting it in there, and they're building buildings. So instead of making it for agricultural use or any other use, it's just becoming high rises, malls, you name it. So it started before 2014, and these little dots you see on here are our sampling sites. And I'll talk more about them. In 2017, when we did our first sampling, the Hun Sen Road was finished across here, and we were sampling the sewage coming into it. So we were looking at the influent, so the water, the sewage from the city. Where does that come in? We were looking at groundwater and surface water wells throughout like a transect. So right near where it comes in, halfway, and where it discharges at the end. And so when I went back there in 2023, you can see the progression of the filling in of their wetland. All of these wet areas, we were there and you would see the bulldozers bulldozing sand in, and you'll see some videos here in a second. Hopefully my videos work. So ideally, a wetland is an ideal treatment facility for wastewater. What we do is in the United States is we do primary treatment, we use sedimentation, we remove the solid particles, we do biological treatment, we break down the organic materials, we then put it into a wetland to polish the water before it discharges. So this system works very well in the United States. Let's see, in Cambodia, what they're doing is they have a metal grate to remove the plastic, some of the big metal pieces. Then it goes into the wetland, and over that entire wetland, it gets treated and then discharged. Well, they're removing that. So what we wanted to know was what happens when you remove the treatment of their wastewater? What impact does it have? So there are raw sewer canals throughout the city. So you'll see these black water throughout there. There's the plastics, but we're going to be talking about microplastics here in a little bit. And then you would think, oh, well, okay, if you're going to fill in your wastewater, your treatment facility, shouldn't you put in like a wastewater treatment plant? No, there is no plant. There is one going in right now. It's a very small plant, and I'll show some pictures of it. The plant size for a city of 2.5 million is about this. The wastewater treatment plant is smaller than the one we have here in DeKalb. So it's really can't handle the amount of waste. And it's a pilot plant. It's not even a full plant. So they're filling in their treatment along the way. So let's see if my video works. Yes. So what they've been doing is you can see in here, this is them filling in the wetland. This used to be wide open spaces, big thing. This water here is black because it is raw sewage. This is raw sewage. It's being channelized right here. They're going to be filling in this area right there. This is some agriculture I'll talk about. And then there's all the city development in there. And then these are the people's homes that we were sampling who use groundwater in their communities. So the sewage is being channelized. I've never seen rapids of sewage before. And I came back from that trip and very excited because to me, this is like, you know, and Dr. Shibata would agree with me. These are the exciting things that we do. So what we wanted to do is investigate this sewage lake to see what is going on from a water quality and what do people use for drinking water nearby. So one of the things that the sewage lake is also used for is farming. So besides treating the sewage, it's also used for farming. So what they do is they put these mats on, these reed mats, and then they grow morning glories and water mimosas on them. So if you've ever been to Cambodia and you've had morning glory soup, it probably came from sewage. So I did not touch morning glory soup when I was there and stayed away from it. So it's grown, it's an aquatic plant. So they grow it right on top of the sewage. I'm not an agricultural person, so I did not test the plants. So I'm going to say that right now because everybody asks me, and I'm like, I'm a water person, not a plant person. So we also looked at, let's see if my video here. So one of the other things we looked at is, and you can kind of see it in the video here, they're spraying pesticides, fertilizers onto the agricultural crops there. This is one of our sampling sites. These are the homes that we were sampling, their well, and then you can kind of see the beige in the background. That is the sand that they're filling it in, and then these are the people's homes right here. We asked them about the types of pesticides that they used, and they go to the market and they just take whatever they can get. A group I worked with, the French, had done a survey, and we're going to be working on a project looking at all the different pesticides that are used down there. So we started off at the influent. So this is the raw sewage coming from the city into it. And this is the pilot plant that they're building right now. So this is the construction. So got to see some of the construction while they were building it. And then these are from the exact same location. So for 2017, open agriculture, 2023, solid land. This is a mall. This is icon or the number 3 mall. It's this humongous mall. One of our field sites is now under it, so we couldn't sample there anymore. And so these some of these sticks, there were some ones that were red that were up nearby there. We asked the locals what those were for, and they're like, "Oh, that's where the road is coming through. Our homes are being, and where are you going to go?" They didn't know. They just know that the road is coming right through their house, and so they didn't have an idea of what was going to be happening to them. And then we studied the end of the lake, the effluent part of the lake. So we studied where did the water come out, and then it went into another river. And you can kind of see in this picture here the 2 different colors of the water. So this black water is the sewage. This beige water is the tributary that it discharges into. It's right here. And so we did a lot of chemical fingerprinting to make sure that we were actually sampling the effluent to see across this transect through this lagoon in 2017 versus 2023. So we are still analyzing some of the results. I'm going to talk a little bit about some of the results, but we're still working to finish up the analysis that we did. One thing we did notice back in 2018 was that across it was working. There is what we call ecosystem services. The wetland was acting as a service. It was working. And so we're trying to do the transects right now, change in land use. So this is my project for the spring, is to really finish analyzing all this water. I show this picture because this was the house that was going to go under a road. And he had just gotten a fish, and a fish came from the sewage lagoon. And I asked him, and it was still alive. And he's like, "Oh yeah, we have to put it in clean water for about 2 to 3 days to get rid of the bad taste that's inside of the fish before we could actually eat it." So this was going to be his dinner in a couple days. Yeah, I know. I'm like, "Ugh." So we did this again, this fingerprinting. This is a very common thing that we do, which is called Piper diagrams. And we were looking at the water quality and the changes in the water chemistry. One of the things that we're noticing is that all the groundwater samples are moving closer and closer to fingerprint of sewage. So the groundwater, which is 50, 100 feet below the ground surface, we're starting to see that become closer and closer to sewage. One of the questions we had was, is the groundwater coming up, the sewage water going down? And so we wanted to look at it in wet and dry season to see if maybe that changed. We went from wet season to dry season, we were in there. One of the other things we used is stable isotopes. Stable isotopes are basically we're looking at the actual water molecule itself. And when we look at the water molecules from back in 2017 versus 2023, the blue dots on here are the surface water, the orange dots are the groundwater. And we saw a separation between those two. But now when we look at the water, it's all on top of each other, showing that those water molecules are the sewage. So the sewage is getting into the drinking water supplies for the community. Some of these outliers are the water samples of areas that are like our background samples, just so you know. One of the other things that we did was we looked at heavy metals. And so I'm just going to talk a little bit about heavy metals here. So again, we copied at the beginning, middle, and end. One of the things that we noticed, and this is in red here, is arsenic. There's a big problem with arsenic in the area and arsenic contamination. And we did see arsenic in all seasons in the groundwater. So we were seeing high levels of arsenic. Some of these levels, the maximum contaminant level for arsenic is 10. And some of these wells, it was 175 parts per billion.
Do you know that's inorganic or total or
For our arsenic, we use the ICP-MS, so it's total arsenic, so it's not in any speciation. We can't, with our particular equipment, we can't talk about speciation. And the MCL is really set on total. So yeah, so it would be really interesting if we could do that separation. We should talk. It could be. It could be. So that's one of the things that, oh, that's a really good point. We should try to see if it is from that. We don't really see it. We see it a little bit in some of the surface water samples, but it's really only in the groundwater samples. The other issue that we had is iron, so iron and oxides. The other big one for me is manganese. Oh, I was just gonna, before I go on to the next slide, I'm gonna just highlight this bottom one. We tested the tap water in Phnom Penh because we're like, well, we should test it to see is the water okay, even though we're not drinking it, but still, does it have our, you know, and the water came out great. I mean, it was fine. The water in Phnom Penh comes from the Mekong River. It is treated. It did not have any heavy metals. So from a heavy metal point of view, it's great. There is some E. coli. So diarrhea versus neurological problem, you know, pick your poison here. So one of the other issues that we had was manganese. So manganese right now is not regulated, but it is being shown at high concentrations of the concentrations we were seeing in this water, especially in children, to cause neurological diseases, neurological decrease in IQ, changes in behavior. So there was a lot of manganese. Manganese teaches the water black. So if you ever see black color in water, it's manganese. The red is iron. So some of the things that I pulled out of this data is that in dry season, we see higher concentrations of aluminum, titanium, magnesium, iron, and arsenic in the surface water. And then in the winter, in the wet season in October, because of so much rain, it dilutes out those contaminants down below it. So the solution to pollution is dilution, right? So we should just dilute all the pollutants down in the wet season. So that's one of the things that's happening, is we're seeing dilution with the rainwater. The surface water has higher concentrations of, except for arsenic and manganese, is found inside of the groundwater. The sewage is not a source of the arsenic or the manganese. We did not see those in the sewage influent, but we did see arsenic, manganese, and iron in the groundwater. And then the tap water was safe. So we are seeing some differences into here, and we still have some work to do. So some of the next steps that we're going to be taking, and this is a group of students from ITC who are helping me out. We're going to be looking at microplastics. We collected samples, and we're going to look for plastics in the water. That's another, I'll talk more about that in a little bit. We're going to be looking for the pesticides. So exactly what Dr. Shibato talked about. We're going to be looking at pesticides into there. So I extracted out pesticides from the water. We're still doing that analysis right now. We're going to be doing some geochemical modeling and then finish up the isotopes into there. And so we're going to be working on this. So hopefully you'll have me back in about a year from now. I'll have all the finished analysis, and I can just talk about this project and the final results from it in there. Depending on time, I have time. Okay, so while I was in Cambodia, I did a second project at the Institute of Technology of Cambodia, ITC, and they were working with the Research Institute of Development from France, and they were looking at agriculture and irrigation issues. So what they wanted to do was look at the areas, and this is south of the city of Phnom Penh. This right here, these are irrigation canals for all the agriculture. So it could be corn, rice, you name the mangoes, whatever. The French put in these irrigation canals along the river. And what they did was they maintain and they put these canals in, and then the farmers use these canals to water their fields during the dry season in there. And so they wanted to look at the water quality and the changing dynamics of when it was dry season versus wet season, and the impact of maintaining these canals. So we were looking at two different canals, Prek Chang and Prek Twitch. So one of them was being maintained by the French. So the French came in, pulled out everything, relined it, made it all really nice. And then the next one over was not maintained at all. So we wanted to see, did that make a difference? So we were working in this area down here. So this is the nice maintained one in here. And so what the farmers do is they take, they have these pumps right here. They pump from the canals up to their farm fields, and then in there. And then this one here is fragmented. It isn't maintained. They don't have the nice walls or anything like that. And so it was a comparison between these two canals. Then when they pump the water up to the top, along the base of their farm fields, there are these discharge pipes. And what they're doing is as the water is coming in, the water needs to discharge somewhere. So it can either go into the ground, but because of a lot of clay in the area, it forms what's called an aquitard. So the groundwater can't go down into it. So they put these pipes into here so that the groundwater can discharge back into this river. So we were sampling what was going through the agricultural fields, what was coming up, and then some of the deep wells in the area. And not deep wells, but actually they're really shallow. I'll show you in a second. So we set up a mobile chemistry lab. I just don't do chemistry in hotel rooms. I also do it in the back of vans. And so we train everybody on how to do the chemistry. And so we're sitting there doing the chemistry as we're pulling the water samples. And then this was a drone picture of us at Praktuich. And then we installed a well. So this is, as you can see, we are just using a hammer here. We're just hand pumping and hand pushing in this well right here. This is a mango farm that was right there. And they had a deep well, and then we wanted a shallow well to be able to see what the differences were in the water quality. So we brought the water back to the laboratory. We ran an IC, and we worked with Dr. Chitwitty on trying to get their IC up and working. They hadn't calibrated it in the last 5 years. They hadn't changed their columns. They weren't, so when we were there and we were talking to them about their instrumentation, we're like, you can't trust any data you collected over the last years. And so part of our job was to like set up protocols for how do you calibrate, running negative controls. So this piece of equipment is phenomenal. This is equivalent or better to what we have, but it hadn't been calibrated. And so part of our job was just even working on lab protocols. So we brought back the water, and we looked at the water, and what we're looking at is, again, these Piper diagrams looking at the water quality. So we sampled, this is a well that's inside of a mango farm. And we sampled, PC stands for the maintained one, PT is the unmaintained one. And we were looking at like their specific conductivity and specific conductance, which is how salty is the water. These two samples here are groundwater. And so what we're seeing is extremely high salt concentrations in these wells. And when we talk to locals about their water, they're like, yeah, if we put in a well, it's just salt, it's pure salt. So, so they don't use the groundwater at all. We looked at the surface water. We started seeing high levels of phosphates. We didn't see nitrates, but we did see phosphates inside of the water. And then we looked at heavy metals. The heavy metals, the ones that stand out again are arsenic. Again, we're at one of the wells. The deeper well was at 563 parts per billion arsenic, and the legal limit is 10. The well we just put in, so we hand pumped it in. It was only about 2 meters deep below the ground, and it was at 40 parts per million arsenic. So they can't use the water for arsenic. That's high in iron, again, and high in manganese. So the solution for the people there is not groundwater. And so what we think is happening in the area is the groundwater, there's an aquitard right here. It's filled with arsenic, iron, and manganese. And they're pumping the water up and they're recycling the water where the agriculture is. So the agriculture is not getting exposed to this high iron and manganese water. It's actually growing in just the irrigation water. So that irrigation canals are extremely important for keeping agricultural going in the systems that are there. So we're going to be looking at shallow groundwater links to irrigation, and we're going to be looking at pesticides. So we're going to be doing all of these samples. We're working right now with Southern Illinois University in Edwardsville to increase the pesticides. One of the problems we had was when we sent them some samples, they're like, okay, they had their standards for US-based pesticides, the most common ones. And they're like, we see pesticides, we see things in your columns, but we don't know what they are. So we had to buy a standard of all the pesticides of the world, ones that are banned around the world and different ones, in order to be able to see what they're actually putting into these fields. So we don't know for sure what pesticides are being used yet. So we're still working on trying to increase our sensitivity of our analysis. And then last and definitely not least is Thailand. So we're going to be talking a little bit about Thailand and some of the different impacts on groundwater there. So for Thailand, oh, I'm sorry. My watch doesn't understand my talk. Hopefully you all do. So groundwater in Thailand, 70% of the water, especially groundwater, is used for of the water is used for agriculture, and Thailand is the world's leading exporter of rice. One of the main issues with using groundwater in Thailand is the central plain around Bangkok. The city is going through land subsidence. So the whole city itself is sinking because they've pumped so much groundwater out in that area that the whole city of Bangkok is sinking down. And so they started just a few years ago, the Department of Groundwater Resources, in order to be able to start looking at the subsidence issues, put in some wells, monitoring water levels, and ban groundwater extractions around Bangkok in order to stop the subsidence from occurring. So we are piggybacking on all these wells that they've put in from the Department of Groundwater Resources to look at water quality. In the country of Thailand, and even in Cambodia, there's not a lot of hydrogeologists, or there's none. So in Thailand, we could identify 5 people with a PhD in hydrogeology. I can name 5 people in DeKalb who have a PhD in hydrogeology, so well, 3. Yeah, no, 4 people, no, 5 people in DeKalb who have a PhD in hydrogeology. So one of the things that's lacking is this introduction of groundwater and groundwater research and groundwater just research on it in these countries. So that's part of what we've been working on. In Cambodia, we're working on a review paper of all the research that's been done on groundwater outside of arsenic, because arsenic they know, and that was usually like the UK coming in and just like, where is arsenic, and talking about arsenic. Outside of that, they really haven't done a lot. So we're trying to improve the idea of what kind of research and water related activities could you be doing in Thailand. So our main projects there, we're looking at, I worked with the faculty at Mahidol University, and we spent quite a few days like going over what kind of projects could we be doing. So we kind of came up with a couple projects where we're looking at these wells, and we wanted to look at antibiotics and microplastics. So one of the big areas that I'm working on in the United States and around the world is what's called contaminants of emerging concern. These are contaminants that are not regulated yet, but are found everywhere, and should we be worried about them? The manganese I talked about before is a contaminant of emerging concern. People are worried about it, but we just don't have regulations. Other ones are like antibiotics and microplastics. Why are we concerned about antibiotics? Well, fish farms. So a lot of the fish, as you know, if you've been to Southeast Asia, a lot of the protein comes from fish and fish products, from seafood. A lot of it is grown in farms, fish farms. And so I'll show you some of those. And the fish are on top of each other. So they put a lot of antibiotics in there in order to control infection in there. And so the fish can grow in there. And we also have discharges from sewage. So going back to my sewage story. And then microplastics. This is becoming a major concern in the United States too. What do we have microplastics anywhere? And where it's going on. And so from landfills, we know that we have a layer of plastics on this planet. In the future, this is just going to be a plastic zone on the geology of our planet, because we have just so much plastics everywhere. So we look at antibiotics because whatever we take into our body, if we don't need it, it gets excreted into our urine, or there's a metabolite that comes from it. but a lot of times it is used for animals and in breeding. It can cause, if we have too much antibiotics in the environment, we can get antibiotic resistant microorganisms occurring. So this is a big concern for people. And one of the reasons that we're really worried about it is in the surface water. This has been done in Thailand, which is an upper middle income country. They use a lot of antibiotics. So the use of antibiotics in their country is pretty high. Not as high as Vietnam, but it is very high. It's a lot higher than a lot of the other countries. And when they looked at surface water in a canal not too far away from the one we were studying, they were finding antibiotics into there. So this is ciprofloxacin. If you've ever gone to the doctor and your doctor gives you Cipro to go, you know, oh, here, take this. This is what you're taking. They were finding concentrations above where this would start to cause environmental impacts in Thailand. And then oxytetracycline, they were finding high concentrations of that in the rivers. And again, I study groundwater. So is this antibiotics moving into the groundwater resources and causing a problem? The other issue that we were looking at, oh, I'm trying to get rid of the thing at the top. Oh, sorry. Microplastics in groundwater. So the theory behind this is that microplastics are, as plastic is used up, let me go back. Now I'm going the wrong direction, sorry. As plastics are put into the environment, they break down into smaller and smaller pieces. And as those smaller and smaller pieces get into the environment, they can then migrate into our drinking water supply. So these microplastics in themselves, we don't know. This is part of the research that we're working on, as my group over here knows. We're really worried about, do these plastics cause any problems in there? But they do know that some plastics contain endocrine disrupting compounds. Some of them have toxic compounds. And the other thing they can do is plastics can absorb other like heavy metals and transport it. We've all made spaghetti sauce and put it into a plastic container and it turns red. That same idea, the plastics can absorb different things into it. So can those get into the water supply? And so part of the problem, and this is one of the issues we had with this research project, is everything we use to do work in groundwater is plastic related. From the PVC pipes to the tubing to the balers we use, everything is plastic. So how do we separate out what we're actually sampling from the sampling equipment itself? And so this is one of the big issues that we have in this research. One of the nice things for us, it turns out, and you'll see in the wells here, everything that we wanted to use, the PVC pipe was blue in color. So we just discounted any blue plastics we found, saying it came from the actual well material. So we went around and we sampled an area in Nakhon Pathom, which is west of Mahidol University, where they do fish farming, and then there was landfills there. So we went to the Department of Groundwater Resources. We got permission from them to sample their wells that they had already installed in the area. So we went around and we found all these fish farms. We also found chicken farms, and we located the wells and groundwater and surface water spots close to each of these locations and these large poultry farms. And then our main research area was this landfill that was right here. And all around it, all of these areas here, these are all fish farms. So this was a big area for fish farming, for the fish that go into the city of Bangkok. This was a lot of the fish that was coming out of here, and it was right next to this landfill. And this landfill was not put in properly. It's not a sanitary landfill with a nice liner. They just dig a hole and they're burying their trash into it in there. So we went around and we looked at some community wells. So these were wells that the city provides, to the water that they provide to the communities. We sampled some of their water from there. Om here, she's going to be starting in January and working on this project. So we've got a Thai graduate student starting very soon. And we went out to these wells that the Department of Groundwater Resources had put in. And each well was one shallow well and one deep well at each location. And we sampled these wells. They were just open and easy to get into. So we sampled them. Oop. Some of the wells, you can kind of see them right there. There's the wells in the corner. This sign in Thai basically says, do not dump trash here. And people were dumping trash in here. And when we came back the second time to sample, the city had, or somebody had put up a fence across here. And so we had to kind of like go through a hole in order, because they're trying to stop people from dumping in this area. And so we sampled these wells that were right next to it. Each of the wells is labeled. We could go online and get some basic information about each of the wells. And this is the fish farm. So this is one of the lagoons that's filled with fish inside of them. The smell, I wish I could have smell vision with some of my research. You guys could smell the sewage and the fish. Okay, maybe you don't want to, but this is the smells of this was just, yeah. And then this was the landfill right here. So you can just see that layer of plastic. So some of our preliminary results, again, we're still doing the analysis and finishing this up, but the municipal water really didn't have any issues. That water seemed to be fine. We didn't find anything wrong with it at the time. So there was no heavy metals. There wasn't any nitrates, phosphates, or anything like that. The shallow and deep water wells were very different. So the shallow versus deep wells, the shallow wells were about 30 to 50 meters deep. The deep wells were greater than 124 meters. The shallow wells had all the problems, not the deep wells. So the shallow wells had high conductivity. Again, going back to that salty idea that we heard of in Myanmar, that salt, that high levels of salt, that was there too in their shallow wells. When we looked at the heavy metal concentrations, we start to see that manganese. We saw selenium, we saw uranium and lead in the water. These are all indicative of rock weathering. So these contaminants, we didn't find arsenic, but we found manganese, selenium, uranium, and lead in the water there. And that is showing weathering. So it's not human contamination. This is coming from the geology itself. But the shallow wells also had nitrates and phosphates, so the agricultural problems. So it's the shallow groundwater in that area is really just a horrible mess. The deeper water was better. It did not have any of the heavy metals or the agricultural pollutants. So you're going to have to go down 150 meters to 200 meters in order to be able to get water that, if you're going to use it for irrigation, is good water quality. And if you've ever drilled a well to go that deep, it's really super expensive to be installing wells at 150 meters down. So our next steps are sampling more of the groundwater to finish inter-lab comparisons of antibiotics. So we're looking at antibiotics along in there. And I'll talk about the microplastics in a second. We're finishing up the heavy metals and the isotopes and all the other work. And then we'd like to go back during like wet season and dry season. And like I said, here, she is going to be starting in January. And so she is going to be taking on this project. So she's going to be able to do all the geochemical analysis, go back and be able to finish up the sampling and being able to talk about what is going on and come up with a conceptual model for the system. One of the things that we just got is going to be here in February, late February, is the group over here. Again, it's all of, I keep pointing over here because it's our little group here. We just got a National Science Foundation grant for what's called a LDIR. It's a laser that can identify microplastics in our samples, identify them and size them for us. And this equipment's going to be installed in late February. So while we were over there, I collected samples. We'll be collecting more samples. We have samples from Cambodia. We're going to be analyzing these samples to be able to look at microplastics in the water in there. So that's coming. And then in the future, especially for Thailand, one of the things that I'd like to be doing is more capacity building, training the professors and the teachers. We just signed an MOU with the Faculty of Environment and Natural Resources at Mahidol University to be able to be doing more collaborative work and projects between the two agencies. So there's a lot of different projects. We could be doing managed aquifer recharge, there's transboundary water issues, there's agricultural issues, putting in regulation, stations and doing just some basic modeling of where is the water coming from and going to, so we can give best practices to people about their water supplies into there. So that's all I have to say today. This was part of my Fulbright. So just some concluding thoughts. Groundwater is important. And I think that this is one of the things that we as NIU can be doing, is going around and talking more about groundwater and helping with this. Groundwater is going to be very important, especially with development in these areas and climate change. There needs to be more research and increased teaching capacity on groundwater sciences in all of these countries, especially if you think of groundwater as your bank, or we'll put in a well and we'll use that for drinking in the future. And especially during wet season, groundwater becomes really important, because that'll help recharge, or do we do active recharging of that excess water to save it for other future. So the other thing is that we're cultivating strong foundation of research in Cambodia and Thailand. So we're developing these research projects with these different institutions. I'm worked on a couple different research proposals. And right now I'd love to be doing more exchange of students. So we're bringing one Thai student over, but I would love to bring more Cambodian students over and have NIU students going over there. So I would like to be doing more, and a lot of the universities would love more development on that. And with that, I will take any questions. And if you'd like to get a hold of me, I have every form of communication available in there. So if you're in Thailand, it's Line or WhatsApp, or Telegram if you're in Cambodia. And with that, I'll take any questions. Thank you. And if you're online, you can always do the chat, right? Okay.
All right, so I have a quick question. In a lot of especially in Southeast Asia, where a lot of these countries have had to deal with a lot of sustained war, the legacies of colonialism, there's this impetus to develop very fast and to have very fast economic growth. But as we can see, and as I was there this summer, there's a lot of environmental degradation that comes from that. And it's sort of like this kind of dilemma, because a lot of this economic growth is tied to things like the livelihood of people, their incomes, national sovereignty, especially in a much wider global context. And so I'm just curious, because these all come at great environmental cost. It's sort of like, well, we're developing our economy, but yet we have an environment that is being depleted and extracted and polluted. So I'm just wondering, in your case and in the conversations you had, what sort of conversations about sustainability paired with development were happening, if at all?
Yeah, those conversations, so the students that were there recognize the issues, but some of them never even thought about it. So part of what we did was we took some of the students from like ITC out to go see these areas, and they'd never really thought about like, oh, what is this development doing for the sustainability of the area? And they never knew what happened to their wastewater. So some of it is education, just to even let the population know, because again, like you said, when you don't have food, or you're living, and then this, do you really, how do you care about something else? One of the other issues that came up, especially in Cambodia, was these areas that are being filled in is all going for the ultra rich. So no one owns water. So what happens is that area above the water, nobody owned that land. So all of a sudden, if they fill it in, now they can own it, and they're building these extremely expensive homes in those areas. One of the faculty members that I've been working with at ITC, he has a house near the Royal University of Agriculture. So you know where that is. I can pull it up on a map, but he's right over there. He was having a house built. Well, even in the dry season, their first floor was getting flooded out. Well, and these areas I was working in, their homes were being flooded even in the middle of the dry season. It hadn't rained in 3-4 months, and their homes are being flooded. Well, it's because when you take away all the capacity of that lake, of that wetland, where is that water going? It's not like they're decreasing it. It's not like they're putting that water somewhere else. It's going into these areas. So when we talk to a lot of the people who live there, they're like, yeah, low life expectancy, who are living in those areas. They don't know what they're going to be doing into the future because they know that this is going to be underwater, or, wealthy people are buying their land. So when we talk about sustainability, we're like, why you're taking away the ecosystem services of something that was working to build home. Could you go somewhere else? But so there, that idea of sustainability isn't there. The other wetland that's on the north side of Phnom Penh, what they're doing with that wetland, which is just as bad, is they're filling in half of it and they're making the other half deeper. Well, a wetland only works because it's shallow water that goes through plants in there. A wetland isn't deep lake. So basically they're going to be filling it in with sewage and they're going to have this deeper lake of just raw sewage that then has to be discharged somehow. So when the flooding occurs during wet season and you've got the reversal of the Mekong and into the Tola Sap, you're going to just have all this sewage running into it. So to me, it's like even just dealing with, and that's not even sustainability. We're just talking basic infrastructure with sewage. It just needs to be handled.
In the flooding in Phnom Penh this summer.
Yeah.
There are a lot of people that are frustrated by the leaking.
Yeah, they're just so frustrated with it. And so I think that this is a really good part where we could be talking about history, political science, all these different things and how it's impacting today. So yeah, other questions? Yeah, Scott.
I was wondering, in terms of
Pass it around.
Thank you, Mel, for your presentation. I really enjoyed it. I was curious, in terms of your host country partners, are they mostly academics, or do you have any political decision makers in your circle of influence there, or do your university partners have those political connections, decision makers, people that could make a difference?
I work with academics, so I've only worked with academics. So the only connection we do have is at Mahidol University, Ajahn Anchara, she knows everybody at the Department of Groundwater Resources. This summer, at the end of this summer, there was a Thai-US symposium on the science and technology between our two countries, and I gave a talk about basically about the same things, about the importance of water. So I did talk to the officials about what US and Thai relations could be doing in order to be able to, and I brought up the fact that groundwater was a major part of this, because they were talking animals and all these other issues. They weren't talking about groundwater. So I brought up groundwater to bring it forward. The problem is the Department of Groundwater Resources really doesn't have a lot of, they're just a monitoring. They don't have they're not a regulatory. It's kind of like our USGS. Our USGS is not regulatory. It's just science data finding. It's not the regulatory side. So this is again where we need to be talking more, because I don't have those connections. My idea was to train the university, get the students trained into the science, and then hopefully, and they can go and talk. Or can we be developing these relations? I know at Chiang Mai University, we're starting to work more with, because of your work and work of other faculty members here, we're developing that with the political, public policy. That's where I gave a talk in Chiang Mai about this, and they were really like, we need to be talking more about this. So I think this is why we need interdisciplinary, we need transdisciplinary research projects where people like myself who know the science behind it and can tell you what's going on can work together with people who know how to do the public policy. How can I translate what we're talking into that regulation? Microphone?
Thank you for your insightful presentation. I actually have a quick question and also a clarification. So I observed that when you were talking about morning glory soup and the fish in Cambodia, everyone was shocked. I'm a student from Cambodia. I just want to let you know that probably because you interview the people living in those areas, so of course that's the actual situation they're meeting. But then the people from the other area, they actually get the fish from the river.
Right.
So yes, thank you. And also, it's kind of linking with what Tom and Dr. Skrafnagel mentioned earlier regarding flooding and politics. The citizens in Cambodia were like arguing why would they fill in the Bang Cheng Ait, that area. So it leads to flooding. And in terms of political point of view, the citizens in Cambodia do not have the capacity to do those kind of non-violent protests because it would go against the government. But then if you want to connect with some urban planning policy makers in the government, I think it's a very best option as well, like he mentioned earlier. By the way, back to my question. So I see some similarities in all three cases that you were mentioning earlier. In Myanmar and Cambodia, where there are high conductivity or very salty groundwater, as well as in the shallow well in Thailand areas as well. So from your point of view as an expert, is there any possibility that we could turn the salty groundwater into the usable water? Because I know there's like a technological advancement in this area. Thank you.
Thank you. Yeah. So the question's about, like, when we have salty water, we can do what's called desalinization. So but it uses up a lot of water, a lot of energy, and produces a lot of waste. So if an engineer or somebody around the world comes up with how to do desalinization really cheap and easy, it could solve a lot of problems of the world. But right now, desalinization uses a lot of oil, energy to remove those salts. So even in your home, if you want to do desalinization or remove that, it's really not feasible to do that. So it's better to not allow the pollution to occur than try to just remediate your salt out of the water. So and you brought up, like, in all of these cities, salinization is a big issue. And it always will be. I mean, this is one of the issues around the world is saltwater intrusion. And especially with climate change occurring, we're going to see more saltwater intrusion. People are going to be pumping more during, most communities live near the oceans. And so when we have more and more of that, we're going to be pumping more. So we need to be thinking about other sources of water, or is there ways to not have it, or is there an aquifer that isn't salty? So like in Thailand, if you go deeper down, you're getting into better water. So can we be able to look at that whole resources of that community and be able to say, okay, you need to drill into this aquifer, then you can use that. Or otherwise, we're going to have problems like what happened in Bangladesh, where they put in wells for people and said, oh, start drinking this water because it's better for you. And then everybody was with arsenic. So we don't want to just say groundwater is the solution to the problem, but we want to make sure that it is clean water before we provide it to people. So I think that's one of so we just need to know what the issues are. If they don't know what the issues are, they can't solve it. So we need to know. That's what part of what I'm doing is just finding what out the issues are. We're at that level. We're not even to like, can we solve it? We're just to like, what's going on issues. So.
But interesting.
Oh, my classes are that way. They always are like, how do you stay happy? And I'm like, well, you deal with genocide. So